Do you ever feel like you're drowning in an ocean of information, but absolutely starving for real wisdom? You watch tutorials, you read articles, you scroll through endless feeds, collecting facts like they're trading cards. Your brain feels like a digital library filled with countless books that you have never actually opened. But a handful of the world's most effective learners, the true masters of skill, do not operate this way at all. Instead of building libraries, they build workshops. Their minds are for creation, not for storage. They are synthesizers of knowledge, not just collectors of information. And the ability to become a synthesizer is not a gift you are born with. It is a skill you can learn. There is a specific method that turns scattered knowledge into deep, applicable skill. It is a framework for thinking that separates the amateur from the master. We call it the synthesis method. The question is not, can you become a synthesizer? The question is if you are ready to learn how. And it all starts by avoiding one critical mistake that traps the vast majority of all beginners. The single most powerful idea that will transform how you learn is this one core concept. Mastery is about creating connections, not about collecting information. Genius is not found in the facts you can recall, but in the relationships you can build between them. For years, we have been taught to learn by memorizing isolated pieces of data for a test. This video is about destroying that outdated model and replacing it with something far more powerful. In this video, I am giving you the complete 4-step synthesis method, a blueprint to master any skill you choose. We're going to walk through each of the 4 crucial stages. First, we have deconstruction, where we break a skill into its smallest possible pieces. Second is assimilation, where we learn how to truly understand those pieces, not just memorize them. Third comes linking, the core of the method, where we build a web of knowledge by connecting new ideas to old ones. And finally, we have recombination, where we use that web to innovate and create something entirely new. Now, to make this all feel real and not just abstract theory, we need a proving ground. So throughout this video, we're going to apply every single step to learning a valuable and complex new skill from scratch. We are going to learn the fundamentals of Python programming. By the end, you will see exactly how to execute the theory, not just understand it. So let's begin with the first 2 steps of the method, deconstruction and assimilation. Most people who try to learn a new skill make a fundamental error from the very beginning. They look at the enormous mountain of a skill like learning to code or playing the guitar, and they get paralyzed by its size. The key is to not try to climb the mountain all at once. Instead, you break the mountain down into a pile of small, manageable rocks. This is deconstruction. Think of any skill like a complex Lego model. It might look intimidating, but it is just a combination of a few basic brick types. Your job is to identify those fundamental bricks. So for our Python case study, we do not start by trying to learn Python. Instead, we deconstruct it into its core components. These are things like variables, which are just boxes for storing data. We have loops, which are ways to repeat an action multiple times. And we have functions, which are like many programs you can reuse. Suddenly, learning Python becomes understanding variables, loops, and functions, which feels far more achievable. But identifying the pieces is not enough, because you must also truly absorb them. This brings us to step 2, assimilation. And this is where we close that open loop from the beginning of the video. The single biggest mistake that traps the vast majority of beginners is passive consumption. It is watching endless tutorials without ever writing a line of code. It is reading a cookbook without ever stepping into the kitchen. This is what separates the library from the workshop. True assimilation is active, not passive. You need to engage with the material, to wrestle with it, to make it your own. One of the best ways to do this is using a technique popularized by the physicist Richard Feynman. The Feynman technique is simple, requiring you to learn something and then explain it in the simplest terms possible, as if teaching a child. If you get stuck or have to use complicated jargon, you have not truly understood it yet. For our Python example, after learning about variables, you would try to explain what a variable is without using the word variable. It is like a labeled box where you can keep a number or a word to use later. This active process forces your brain to build a solid, intuitive understanding of the core concepts. Another powerful method for assimilation is active recall. Instead of just rereading your notes, close the book and try to retrieve the information from your own memory. The act of struggling to remember is what strengthens the neural pathways, making the memory more durable. Do not just watch the master work. Steal the tools and start building. Okay, this is where things get really powerful. Learning the pieces is one thing, but mastery comes from connecting them. This brings us to the heart of the entire system. Step 3, linking. An isolated fact is a brick. A connected fact is part of a fortress. Your brain is a web of interconnected neurons, so it does not store information in a neat list. The more connections a piece of information has, the stronger its memory, and the easier it is to retrieve. The secret to linking is to deliberately connect what you are learning to what you already know. This is called associative thinking. Consider Charles Darwin. His breakthrough theory of natural selection did not come from a vacuum. He was a knowledgeable pigeon breeder, and he understood artificial selection, how breeders could select for certain traits. He then connected that existing knowledge to his observations of finches in the Galapagos. He asked, what if nature was doing the same thing as the pigeon breeders, just over millions of years? That connection between pigeon breeding and wild finches changed the world. So how can you do this systematically? Always ask yourself the simple question, what does this remind me of, when you learn a new concept? Let's go back to our Python example. You are learning about a for loop, which repeats a task for every item in a list. What does that remind you of? It might remind you of a recipe's instructions, like, for each egg, crack it into the bowl. By linking the abstract idea of a for loop to the concrete idea of a recipe, you anchor it in your mind. Now, to do this at scale, you need a system to capture these connections. This is where we can use modern tools to build what some call a digital garden or a second brain. Imagine a place where each note you take is not just a file in a folder, but a node in a web. Tools like Obsidian or Notion allow you to create links between your ideas. So your note on Python for loops can directly link to your note on recipes or your note on assembly lines. Over time, you are not just collecting notes. You are building a visual, searchable map of your own understanding. You are externalizing your thought process, making it easier to find surprising connections. This web of knowledge is the foundation for the final and most exciting step. You have deconstructed the skill, you have assimilated the pieces, and you have linked them into a web. Now it is time to move from learning to creating.
This is step 4, recombination. Steve Jobs famously said that creativity is just connecting things.
Recombination is the active process of doing just that. It is about taking the different bricks you have learned and building something new that is uniquely yours. This is where true mastery and innovation are born. Look at the founders of Stripe, the payments company. They combined their deep knowledge of programming with a clear understanding of the frustrating world of online finance. By recombining these two skill sets, they created a solution that revolutionized an entire industry. The most effective way to practice recombination is through project-based learning. Instead of just studying theory, you force yourself to build something tangible. This approach is fundamentally different from following a tutorial. While a tutorial holds your hand, a project forces you to think. It forces you to confront problems, search for answers, and forge new connections on the fly. So let's apply this to our Python case study. You have learned about variables, loops, and functions. Now do not just study more Python. Build something. It could be a simple project like a weather app that pulls data from an online service. To build it, you will need a variable to store the city name. You will need a function to go get the weather data. Maybe you will even use a loop to display the forecast for the next 5 days. This project forces you to recombine all the individual pieces you have learned into a functioning whole. It transforms your theoretical knowledge into practical, proven skill. Learning is a loop, not a straight line. You learn, you build, you fail, you learn more, and you build again, better this time. This cycle of recombination is the engine of mastery. If you are getting value from this breakdown of the synthesis method, do me a quick favor and tap the like button below. It is a small click for you, but it tells the algorithm that we are creating a community of serious learners here. Thank you. Now let's get back to it. So we have the 4-step method, the engine for learning. But this entire system is useless without 2 key foundations, which are the right mindset and the right environment. Think of this as the fertile soil and clean air your skills need to grow. First, let's talk about mindset. The most fundamental component is what Stanford researcher Carol Dweck calls a growth mindset. It is the core belief that your abilities can be developed through dedication and hard work. This is the opposite of a fixed mindset, the toxic belief that you are either born good at something or you are not. A growth mindset reframes your entire experience of learning. Suddenly, challenges become opportunities instead of threats. Most importantly, failure is a data point, not a dead end. Every time you get something wrong while coding, you are not failing, you are gathering data on what does not work. Just like an athlete who studies recordings of their mistakes to improve their form, you use your errors as fuel for growth. This pairs with intellectual humility, the understanding that you do not know everything, and that is exciting. Next, let's talk about your environment. Your ability to learn is directly tied to your ability to focus, and today's world is an enemy of focus. You must treat your attention as your most valuable resource. This means being ruthless about managing distractions. Use focus modes on your phone and computer, turn off all non-essential notifications, and schedule specific blocks of time for deep work. Technology should be your tool, not your master. Finally, many of you might be asking how to even choose a skill to learn. The answer lies where your genuine curiosity and career utility intersect. Find something that truly fascinates you, but also has the potential to add value to your life or career. Learning is hard, so your own curiosity will be the fuel that keeps you going when motivation fades. With the right mindset and a protected environment, the synthesis method becomes unstoppable. We have covered a lot of ground, moving from high-level theory to practical techniques. Now, let's distill it all down into an actionable plan you can start today. Here is the synthesis method in a nutshell. Step 1 is deconstruction, where you break your chosen skill down into its smallest fundamental components. Step 2 is to assimilate by actively engaging with each component using techniques like Feynman and active recall until you truly understand it. Step 3 is to link by asking, "What does this remind me of?" and building a web of connections between new and existing knowledge. Step 4 is to recombine by using project-based learning to combine your skills in new ways and build something tangible. To make this even more concrete, here is a first 30 days checklist for learning any new skill. Week 1 is all about deconstruction. Your only job is to identify the 20% of components that will give you 80% of the results and start assimilating the first few. Weeks 2 and 3 are for assimilation and linking. Focus on active learning, and for every new component you learn, create at least one link to something you already know in your digital garden. Week 4 is recombination. Choose a very small project and build it from scratch, forcing you to integrate everything you have learned. This structure gives you a clear path and prevents you from getting lost. So here is my challenge to you. Pick one skill, just one. Apply this method for 30 days. You will be absolutely astonished at the results. The great illusion of learning is that it is a mysterious gift reserved for a few chosen geniuses. But the truth is that mastery is a method, not magic. We have seen that the process is not about how much you know, but how well you connect what you know. It is about shifting your mindset from a passive librarian to an active builder in your own mental workshop. So let's return to the question from the beginning. I can no longer be a synthesizer. The answer is not only yes, but you already are. Every time you use a metaphor to explain something, you are synthesizing. Every time you solve a new problem at work by drawing on past experience, you are synthesizing. This method is not about learning a new trick. It is about becoming conscious of a power you already possess. You now have a framework to wield that power with intention. Mastery is not a destination reserved for geniuses. It is a direction. And you now have the compass. Genius is not what you know. It is how you think. Now, I have a question for you. What skill are you going to master with the synthesis method? Let us know in the comments below, because sharing your goal is the first step to achieving it. If this video gave you a new way to think about learning, subscribe for more content to help you build your best life. Thank you for watching.